Section 6-5, Limits of Indeterminate Forms, L'Hopital's Rule. Our objectives for today are understand when L'Hopital's rule may be used to evaluate a limit and how to use it, how to use L'Hopital's rule to evaluate a limit. So suppose you have a function that is a quotient of two functions. F of x is g of x divided by h of x. Now suppose you take the limit of this quotient of two functions as x approaches c. So you have the limit of g of x divided by h of x as x approaches c. You would try direct substitution, and if you get 0 over 0 or infinity over infinity, we say that we've obtained an indeterminate form. What that means is, when you get this, you don't know what the answer is. That's the meaning of indeterminate. There are other indeterminate forms, but you can only use L'Hopital's rule if you get one of these two indeterminate forms, 0 over 0 or infinity over infinity. How do you use L'Hopital's rule? You take the derivative of the function in the numerator. So the function in the numerator is g of x, so you take the derivative of g of x, giving you g prime of x. You take the derivative of the function in the denominator. You take the derivative of h of x, giving you h prime of x. And then you try taking the limit of this new quotient as x approaches c. For this new quotient of the derivatives of g and h, if you are able to find the limit, then you are done. Suppose you get one of these two indeterminate forms again, then you can apply L'Hopital's rule one more time. Let's take a look at a couple of examples. So in our first example, we have the limit of 2x squared minus 2 divided by x plus 1 as x approaches negative 1. So the first thing that you should do is you should try direct substitution. So if you try direct substitution, you'll have 2 times negative 1 squared minus 2 divided by negative 1 plus 1. And what is that equal to? Negative 1 squared is 1, so you have 2 times 1 is 2, 2 minus 2 is 0, and negative 1 plus 1 is 0. So you get the indeterminate form 0 over 0 for the first example. So you can use L'Hopital's rule for the first example. So how do you use L'Hopital's rule? L'Hopital's rule says now you would take the limit as x approaches negative 1 of what? You would take the derivative of the function in the numerator. The derivative of 2x squared minus 2 is 4x, and then divide that by the derivative of the function in the denominator. The derivative of x plus 1 is 1. And now you would try direct substitution and see what you get. So when I try direct substitution, I will have 4 times negative 1, which is negative 4. So I have negative 4 over 1, and that's my limit, negative 4. So I'm done with the problem. I use L'Hopital's rule to solve it. So now let's look at number 2. We also have the limit of a quotient as x approaches 0. So we will try direct substitution. So we will have e to the 2 times 0 minus 1 divided by e to the 0 minus 1. Now 2 times 0 is 0, so I have e to the 0, which is 1. 1 minus 1 is 0. And in the denominator, e to the 0 is 1. 1 minus 1 is 0. So I get the indeterminate form 0 over 0, so I may use L'Hopital's rule. So let's use L'Hopital's rule for this problem. I take the limit as x approaches 0 of the derivative of the function in the numerator divided by the derivative of the function in the denominator. So the derivative of e to the 2x is e to the 2x, and then you have to use the chain rule and multiply by the derivative of the inside function 2x, which is 2. And then the derivative of minus 1 1 is a constant, the derivative of a constant is 0. So now I will divide that by the derivative of the function in the denominator. The derivative of e to the x is e to the x, and the derivative of a constant is 0, so I just have that. So now I'm going to try direct substitution. So when I try direct substitution, here's what I will have. I will have 2 times e to the 2 times 0 divided by e to the 0. And what is that equal to? Well, 2 times 0 is 0, and e to the 0 is 1. So 2 times 1 is 2. And in the denominator, I have e to the 0, which is 1. So the answer here is 2. And before I go any further, I'd like to explain once again why we consider 0 over 0 to be an indeterminate form. You'll observe that in both of these examples, when I tried direct substitution at the beginning of each problem, I got 0 over 0 for both of them. But that is an indeterminate form because, as you can see from our work that we just did, they actually have different limits. So when you get this, it doesn't tell you what the answer is, and that's why it's indeterminate. So we've just seen two examples of L'Hopital's rule, and in the two examples that we looked at, we had the limit of a quotient as x was approaching a particular constant. In example 1, x was approaching -1, and in example 2, x was approaching 0. And L'Hopital's rule says if you have the limit of a quotient as x approaches c and you get either 0 over 0 or infinity over infinity, then you can take the derivative of the function in the numerator, take the derivative of the function in the denominator, and then try to take the limit once again. And if you get an answer the second time around, it is equal to the original problem's answer. There is a variation of L'Hopital's rule. Suppose instead of x approaching some constant value like we saw in the previous two problems, maybe x is approaching infinity or possibly negative infinity as well. So if you have the limit of a quotient of two functions as x is approaching infinity or negative infinity, and you get either 0 over 0 or infinity over infinity, if you get one of these two indeterminate forms, you may also use L'Hopital's rule, take the derivative of the function in the numerator, take the derivative of the function in the denominator, and try taking the limit of this quotient as x approaches infinity. And if you get a limit, the limit is equal to the limit of the original problem. So let's look at two examples where x is approaching infinity. So here we have example 3, and we want to see what we get when we try direct substitution. So x is approaching infinity. So when you try direct substitution, x goes to infinity. So x squared also goes to infinity. So 3 times x squared will go to infinity, and -1 won't make a difference. So the numerator will approach infinity. The denominator, as x approaches infinity, x squared will approach infinity. So 2 times x squared will also approach infinity. +1 won't make any difference. So both the numerator and the denominator will approach infinity. That's one of those indeterminate forms for which we can use L'Hopital's rule. So we can use L'Hopital's rule in this problem. And here's what we do. So we're going to take the limit as x approaches infinity of the derivative of the function in the numerator. So that's going to be 6x over the derivative of the function in the denominator. That's going to be 4x. So now let's try direct substitution again. As x approaches infinity, 6 times x will also approach infinity, and 4 times x will also approach infinity. So we get the indeterminate form infinity over infinity again. So that's okay, we just use L'Hopital's rule one more time. So now we have the limit as x approaches infinity. Now we take the derivative of the function in the numerator. The derivative of 6x is 6, and the derivative of 4x the function in the denominator, the derivative of 4x is 4. So now we have a constant 6 over 4, and when you take the limit of a constant as x approaches infinity, you just get that constant. There's no x here, so it's just a constant. It doesn't matter that x is approaching infinity. The limit of 6 over 4 as x approaches infinity is 6 over 4, which reduces to 3 over 2. So now let's take a look at our last example, the limit of natural log of x divided by x as x approaches infinity. So again, you begin with direct substitution. As x gets larger and larger and larger, natural log of x will also get larger and larger and larger, so it will approach infinity. X will approach infinity, so you get the indeterminate form infinity over infinity. So now we're going to apply L'Hopital's rule. So we're going to take the limit of the quotient of the derivatives of these two functions as x approaches infinity. So the derivative of the natural log function is 1 over the argument, so we will have 1 over x divided by the derivative of x is 1. So this is what we have. And of course you can simplify 1 over x divided by 1. That's just 1 over x. So I have the limit as x approaches infinity of 1 over x. And what happens as x approaches infinity for 1? Well, 1 is just a constant, so it'll stay 1, regardless of what x is. On the other hand, for the denominator, as x approaches infinity, well, I have x, so that will go to infinity. So the numerator stays 1, but the denominator gets larger and larger and larger. And if you divide 1 by larger and larger and larger numbers, the quotients will approach 0. So the limit is 0 here. And again, I want to point out that why is infinity over infinity an indeterminate form? Look at these two examples that we just did. In both of them, when we began, we got the indeterminate form infinity over infinity, but as you can see, these two problems have different answers. They have different limits, and that is why this is called an indeterminate form. So today we looked at when we can use L'Hopital's rule to evaluate a limit, and also how to use L'Hopital's rule to evaluate a limit.